Hello everyone, welcome back. In this tutorial, I'll be giving you guys a very gentle introduction to R. So I'm going to show you some of the basic functions of R. I'm going to show you some of the basic capabilities of R so that you guys have a base for the first few laps that we're going to be doing in class. This is by no means a comprehensive introduction to R. We can spend the entire semester just talking about R. Rather, uh, what I want to do is highlight some of the most important functions and capabilities of R in this particular tutorial. So to get started, go ahead and open your R Studio. Once you have it open, you'll see three windows or three panes. You have the console pane, you have the global environment pane, and you have your viewer pane. Uh, if we're gonna start right here in the console because you can type commands directly into the console. For example, one of the most basic things that you can do with R is use it as a calculator. So for example, I can say I can type 6 plus 2, click enter, and that's going to give me 8. Now, one thing that you should know is that space doesn't really matter with R, so you can space them out if you like. So let's say 6 minus 2, and the which is equals to 4. So sometimes you see me not spacing things out, and sometimes you'll see me spacing things out, and I'll do that most. Essentially, I do it mostly for aesthetic reasons. I like to be able to write code in a way that I can read it easily. So spacing things out most of the time, I find that is more legible, and it is easier for me to look at it and see when something goes wrong. So we have added 2 to 6, we have subtracted 2 to 6. Now we can also multiply 6 by 2. So 6 star 2, click enter, and that'll give you 12. We can divide 6 divided by 2, and that will give us 3. We can also exponentiate. So for example, if I want to calculate 6 squared, what I want to do is hit 6, and then in a Windows, you want to hit Shift and the number 6, and I'm going to give you that up looking caret. And then the exponent is 2, which is square. Hit enter, and that will give you 36. Of course, if you can exponentiate, you can take the square root of things. And to do that, we are going to actually use a function called square roots, but it's actually type SQRT, There you go. And we could take the square root of 9, and that will give us 3. One thing that you'll note is that I'm typing all of this. I'm doing all this quote unquote analysis directly into the console. And while that is completely fine, it really doesn't allow me to save my work or really to annotate my work. So when it comes to R, we typically like to work within an R script editor or an R script file. So to open an R script or to open the R script editor, you're going to click here and then create a new R script. You can also just do it right here. New file, R script. And in this R script, we can do exactly the same things that we were doing in the console. For example, 6 plus 2. Now, the one thing that you'll keep in mind is that in the console, we used to just hit enter, and that will give us the result. that doesn't work in our script. So to run that particular piece of code in our script, you want to highlight it and then click run. Similarly, you can also just if you click right after the piece of code and just click on a Windows, you can click Control and Enter. That will also run that piece of code as well. You can also just highlight and hit Control Enter. That will also run that piece of code. And we can do everything we did in previously. 6 minus 2, 6 times 2, 6 divided by 2. We can also do 6 square. And the square root of 6 of 9. So if we can just run it, you see it's 4. Control Enter. Control Enter. Control Enter. Same thing. You can also just highlight everything and just run it, and it'll give you the answer. So everything you can do in the console, you can certainly do in the R script, right? However, the R script is going to allow us to create a paper trail that is going to be great for replication. So that others can know exactly what we did, but also for ourselves, we are able to reproduce what we did. We have some type of memory to remember what we've actually done or why we did it. And you might think you have great memory, but let's say you run some analysis and a year later, some reviewer asks you to change something, and you get back to the code. You're not gonna remember a lot of times what is what and why you did what you did. So annotating your code is really, really, really important. So to annotate, we're gonna be using the pound symbol or the hashtag symbol, right? So in a Windows, you're gonna click on Shift and 3, and you're gonna create that pound or hash or hashtag. And that symbol tells R, don't run anything that comes after the hashtag, right? So for example, let's do addition in R. Let's do 6 plus 2. If I were to highlight everything here, R is gonna know, well, this is just an annotation, so I'm not gonna run it. And then I'll run this piece of code here, or 6 plus 2, which is equals to 8. You can also use the hashtag to the right of the function or the equation. So for example, 6 square. You can just write hashtag, this is 6 square. Same thing. You can just highlight that and run that, and again, it's just going to run this. It'll do the calculation for 6 square, and everything to the right of the hashtag it will ignore on that particular line. Now, what happens if you forget to put the hashtag in? So let's just copy and paste this and delete this. Let's see what happens. So essentially, R is reading everything as code. It wants to run 6 square, but it really doesn't know what it is. It's an unexpected symbol, right? Following 6 square. So it really doesn't know what to do with it. So it's always important to keep in mind to make sure, well, to at least to make sure to write, whenever you want to write a comment, to put the hashtag or the pound sign. So in this class, I'm really going to encourage you to annotate as much as possible. because it really tells the story what you're doing, and it will help you later. It'll help you decipher what you've done in the past. So now that we have this R script, one of the great advantages of working in R script is that you can save it. You can save this script and open it later. And to do that, you can just go to File, Save, and you can save in the working directory. But I'm not gonna talk about working directories here, but we'll do that in the next video. So I'm just gonna active courses, research methods. Just gonna put it here, Gentoo intro. And now you have a name. You can save it and open it later and rerun exactly what we did here. So when we do the labs in class and I tell you, hey guys, open the R script, that's exactly what I mean. I'm asking you to open some type of .r file that I'm gonna provide you guys. Now let's talk about functions in R. So a function is just an integrated set of instructions that are applied consistently. And within each function, we can apply different arguments. And arguments, you can think of them as just a way to refine the set of instructions that come with the function. So that's the basic language that we're going to be using in this class. We essentially, almost all the techniques that we're going to be doing in the class, we're going to do them through functions, and then you can adjust the settings of those functions through arguments. We already run a function here, and that is the the square root function to take the square root of 9. We've done that. Another common function that we're going to be using in this class, or just generally in data analysis, is the print function. From base R. And what do I mean when I say base R? I just mean that when you download R already comes with a set number of functions that are readily available to you. So you don't really need to install anything extra, any other packages to run that particular function that you want to run. So anything that is base R it just means what comes with default when you download R. So let's talk a little bit about the print function in R. So the print function starts with the function name, which is print, and in parentheses, that's how you know, by the way, that you are dealing with a function. You have the name of the function followed by parentheses, and whatever is inside of the parentheses are the arguments for that function. So the print function just prints whatever you give it. So let's say research methods is cool. Let's run that. And by the way, research methods is cool is a character variable, and whenever you're dealing with characters, you have to put it in quotes. So highlight this, and the print function is just gonna give you is going to print in the console whatever you feed it to, and we fed it research methods is cool. You can also, whenever you're dealing with character data, you don't have to use you can also use single quotes, right? So instead of double quotes, you can just put single quotes on it, and it'll give you the same thing. Now, it is important to remember that R is case sensitive. So as you can see, print is all lowercase. Some functions are gonna have like an uppercase letter followed by everything else lowercase. So it's just good to keep in mind how the names of the functions, how they are written, because if you don't write them correctly, it's not gonna run. For example, let's say I take print again. Let's and instead of saying just print, I'm just gonna say print with a capital P. I'm gonna run that, and we have an error here. All right, could not find the name of the function print with a capital P because print with a capital P doesn't exist. Right, it's only print all lowercase. Now let's say that there's a function and you want to know more about it. How can you get more information? Well, you can go to Google. It's perfectly fine. You can go to Google and find tons and tons of help on Google, but you can also just access help information from here by typing the help function and feeding the function name to that function, which is just going to be print. You're going to run that. And the help function, the help is going to come on this window. It's going to tell you how it is used. You have the name of the function, and then you're going to have some arguments. They'll tell you what kind of arguments you can give it to the function. It'll give you details. It'll give you examples as well. So it is simple. Whenever you are unsure of a function and what it does, where it comes from, is see how it says print base? It just means that this is a function that comes with the default R. So whenever you're unsure about something, you can just type help print. It will take you here, or question mark print, and it'll take you here as well. Either one will be fine. Usually when I do this, when I'm unsure about a function, I don't type it into the R script because I don't want to keep it there. I usually just type it down here in the console because I'm just unsure about how to use it, and I just want to figure it out, and then I just want to continue with my R script. Now, another really, really important concept in R is the idea of a package, right? So anything that comes standard with R or base R is readily available to us, and we don't really need to install a package for us to do it. And base R code is fantastic. There's functions for visualization and data manipulation. However, the thing about base R code is that the functions can be quite cumbersome, and it can become very complicated to do things. And so for that reason, over time, users have created packages that perform really, really sophisticated tasks with way simpler functions. Those functions, however, are nested within these packages. And for you to be able to utilize those functions, you need to install the package and also load the package. So for example, one package that we'll be utilizing quite a lot in this class is ggplot2, which is just a data visualization package. You also have dplyr, which is a data management package. Those packages don't come standard with R. You need to install those packages and then load those packages before you can use them. And so to install the package, so just go up here, packages in R. So to install the package, we're gonna use the function install.packages, and in quotation mark, we're gonna write the name of the package that we want to installed. In this case is ggplot2. Then you can just go ahead in here and run it. And depending on your computer, this could take 20 seconds or it could take a minute, right? We can also do the same thing with install packages, dplyr, and install it. Now, once you have installed a package, you don't really need to install it again before you use it. It now installed into your console. The only thing you need to do before you use it is to load the package. Right. So to load the package, we're gonna use a function library, and not in parentheses, ggplot2. And if we wanted to use dplyr, we would again put library and dplyr. All right. So the way I like to think about installing packages and libraries is that, let's say let's say you wanna, so let's say you have a library, right? There's a local library that you use all the time, and it has certain books on it, like ggplot2. Let's say ggplot2 is a book. Well, the library has the package or the book, right? It's installed already. But before you can actually access the information of the book, you need to check the book out of the library. So that's why we use library, right? To take it out, and now we can use the functions within the package. You can also do this just manually. Just if you click here, packages, to install the packages, you can just click installed and look for the name of the package here and then install it. To load the package, ggplot2, you can just click here and it will load the package for you as well. So in this class, we're going to be relying mostly on packages. I find base R code to be kind of cumbersome and sometimes not very intuitive. So there are a number of great packages for data management and data analysis and data visualization. And this class is going to be based on those packages. So we're going to be, of course we're going to install packages, but we're going to be, loading those packages a lot during the semester. Now, another important idea of R is the idea of object assignment. So R is what is called an object-based language. What that means is that essentially when we open R, what we're going to be doing is that we're going to be creating objects, and then we're going to be manipulating those objects with the functions that we're going to be learning throughout the semester. So those objects, so we're going to assign objects to things. So for example, let's say I want to create an object called X, and that object is going to be, we're going to set it equal to 5. And to assign a value to an object, you're going to have to use the left facing arrow, which is just this, right? And we're going to say 5. You run that. And now here you can see in the environment that now we have a new object X, which is equal to 5. If you want to know what an object is, you can just use the print function like we used above and print X, control enter, and it's going to tell you object X is equal to 5. You can similarly, also, for example, create an object. Instead of using this left facing arrow, you can just use the equal sign, equals to 2, and it will create an object that is A, which is equals to 2. You can now print A, Now, if I were to type, remember R is case sensitive. So if I type capital A and run that, it's not going to find the object because there's no such object that is capital A. It is lowercase a. So that is really, really important to remember. Usually when your code is not working, it just means you probably misspelled something. So there's two ways to assign values to an object, either through this left facing arrow or the equal sign. I prefer the left facing arrow, and you'll see me doing that, but you can use the equal sign as well. But I think this just makes more sense. You can also assign characters to objects. So for example, we're gonna assign to Y. We're gonna assign to Y research methods is my favorite class. Exclamation point, of course. And so if I were to do print Y, now you get research methods is my favorite class. Lastly, I want to talk about the types of variables that we're going to be encountering in this class. I mean, we've talked about numeric and categorical variables, but in R, there are a little bit more detail. There's a little bit more detail that you need to know. In R, you have numeric, which includes decimals and integers, character data. You also have date data, as in dates, and logical, sort of true false type of data. And we can use the function class to find out what a variable is, what an object is, right? What kind of object are we dealing with? Object, let's say X, it's going to tell us that it is numeric, right? Because it is a number. X is 5, so X is a number. We can also use the function str for structure X, and it's going to give us this numeric, and it's just going to tell you the numbers. Now, within numeric data in R, R differentiates between numeric data and integers. And if you guys remember, integers are just sort of whole numbers that don't have decimals. And sometimes we're going to have to change a variable from numeric to integer. So change X in integer. And to do that, we just, again, use X, use our little arrow here, and we're just going to put 5L, and the L is just going to tell R that this is an integer. Later on, I'll tell you a more, I wouldn't say easier, just I think a more intuitive way of doing this. Oh, see, it gave us a little unexpected symbol because it's not just lowercase l, it's capital L. See? So now if I say class X, it's going to tell me this is an integer. Why is it important? Why can't it just be numeric? Well, because some functions are very strict as to what they want. Some functions just want numbers. It doesn't matter if it's decimal, or it has decimal places or not. And some functions want that number to be an integer. So it's just really important to know that. Um, we can do the same thing if we go, let's see, character. For example, if I type the function class and I feed it y, and it'll tell you that this is a character level data because it's in quotation mark. So the last thing I want to talk about is sort of the difference between a vector and a list. Now, in this class, we're mostly going to be working with, actually, we're almost exclusively going to be working with data frames. But I want to introduce you to these two types of data so that, because you might see it out there in the wild, and I want you to at least know what they are. So, vectors versus lists. They're both pretty much the same. So, what is a vector? A vector is just a sequence of consistent data, one type of consistent data, right? So, let's create a vector. Let's call it V. And it's just going to be a sequence of values of consistent data. And to do a number of values, we're going to use the combine function, or C. And in parentheses, we're just going to type 1, comma 2, comma 3, comma 4, comma 5. So this is a sequence of values. So you can just highlight and click run and see how you have 1, 2, 3, and 4. And if you were to do print V, you have 1, 2, 3, and 4. This is a vector because the data type is consistent, is the same. This is numeric data across every one of those values. You can also create a vector of character data. So for example, let's do U and assign to you a list of characters, sort of yes, yes, no, yes, no. Highlight that, and now you have a vector of characters, and you can run print U, and you see yes, yes, no, yes, no. Right? A list is a sequence of data values, but they're not consistent. They can be many different things. So let's just use L for list, and let's assign to L. We'll use the list function, and we'll assign it. For example, we'll do an integer, so like 3L for integer. We'll do no. We'll do some logical data, and we'll do some just random number like 99. And if we run that and print out, you'll get the list 3, no, true, 99. I know it doesn't seem like it is a substantial difference, but it does make a huge difference in certain cases. So this is all for now. I think for now that you've, for example, done creating this R script, you can just now save it. It's a good idea to save it. And to quit R, you can just go to File and Quit Session, or just click the X button or the Quit button right here. Again, this is not meant to be sort of an exhaustive introduction. I'm just highlighting a lot of the different things that we're going to be sort of using, a lot of the concepts and capabilities that we're going to be using throughout the semesters, and some that we're are not going to be using all that often, like vectors and lists, but I think it's good that that you will see them. Well, that is everything for now. Thank you so much for watching.